one macro change that you probably familiar with is the transition from VMware to a more like open
To bare
source,
metal or
exactly,
Kubernetes based. Yep.
containerized environment, Kubernetes. So this is one trend, and the other trend is AI. The two combined together, right? So the Kubernetes kind of become the default, let's say, orchestration platform, and the workload become AI workload. But
welcome to Embracing Digital Transformation, where we explore how people, process, policy, and technology drive effective change. This is Dr. Darren, Chief Enterprise Architect, educator, author, and most importantly, your host.
On this episode, AI, Data, and the Future of Infrastructure with Iran Kerzner, CEO and founder of Lightbits Labs.
Iran, welcome to the show.
yeah, thank you, Darren, for having me. Yeah, it's great to be here.
Hey, I'm really excited about the topic today because it's very practical and it's kind of the foundation that makes AI move forward, which is the data. I need data to make all this happen. But before we dive into data and AI, everyone that listens to my show knows that I only have superheroes on the show, and every superhero has a background story or an origin story. So, Iran, what's your origin story?
Okay. How far you want to go?
As far back as you want to go. If it's interesting, that'll be great. If it's boring, I'll cut you off and we'll move forward.
Okay. No, just joking. So, yeah, Iran Kerzner, I'm the kind of founder and CEO for Lightbits. I started my career more than 20 years ago. You'll be surprised. Actually, I was started doing a silicon chip. I was an architect in Motorola Semiconductor. You remember back then, there was kind of two giants. There was Intel and Motorola.
And Motorola, that's right, yeah.
These days, people do not appreciate, do not even remember that Motorola Semiconductor, together with PowerPC, Somerset, if you remember, they were kind of the king. So I was a CPU architect.
Did you work on the 68,000 chip?
I work on the PowerQuick and PowerQuick 2, this kind of, devices.
That was those were great chips.
Yeah,
I can't say they were better than Intel chips because I work for Intel, but they were better than Intel chips.
I can tell you, when I just graduate, I had two offers in my hand, Intel and Motorola. And as a kind of graduate from school, you see which one I can go, right? Both of them are great. Both of them were building the best CPU. And it was a really tough decision. And, it's like the movie of kind of swinging doors, thing like that. I don't know how my life would be if I was Intel or in Motorola, but I choose Motorola. It was kind of a combination of going to compute, networking, and storage, because it was kind of and back then those CPU, basically, if you remember, they power even the Apple. We just talked about Apple before, so they power the Apple machine, and then Apple flipped to Intel, and then they flipped their own silicon.
And they flipped to their own, yeah.
Well, this was an exciting time in the kind of in the silicon building kind of CPU, and I kind of learned everything that you need to learn about compute, storage, networking, because it was all together. Later on, I moved to a startup called Wintegra. It was people that actually spin out, you may say, from Motorola Semiconductor, and not unexpectedly, we had a site in Austin. So I spent a few years in Austin, Texas, and we had a site in Israel, and we built one of the best kind of network processors. Remember, there was a time there was a hype about network processor.
I remember,
and it was very successful. And eventually, the startup was acquired by PMC Sierra. But before of that, we basically kind of a very kind of dominant position with a customer like Cisco, Ericsson, Nokia, Siemens, and kind of SoftBank and others. So it was pretty exciting time of being in the leading technology, and it was leading because this actually what was the foundation for LTE. For everything that every base station, ASN gateway, all of that. So I got kind of the opportunity to be in kind of the compute intense how to kind of process and kind of CPU intensive, and then moving to networking, and everything related to communication. And then as part of PCC era, the CEO asked me kind of to be part of a new group, that incubation team, and leading kind of some of the development of the flash controller. So shift from compute to networking to storage. So we basically built
That
the first
is
NVMe controller that went to the market, and this actually what led me later on to starting Lightbits. So building the first NVMe controller went to the market. It's used by the top hyperscaler, by most of the storage vendors, and it was a phenomenal from that perspective. Really being in so I had the opportunity, or the kind of this is why I was joking of I don't know how my life would be if I would start here or here, but I had the opportunity to be in the bleeding edge technology in each one of these domain. And now I feel the same thing with everything related to AI and kind of data centers and neo cloud. But I guess that's the next part of our discussion.
well, this is really interesting because you're actually very unique, and your superpower is that you've got to be, because most silicon engineers get stuck into CPU or into network controllers or into, and you've had the opportunity to handle the whole compute domain, which is compute, storage, and network,
Exactly.
right? Which is incredible. And now you're actually delivering products to end customers instead of just focusing on a piece of silicon, which you and I both know. When you're down in the architecture of a piece of silicon, you never talk to customers, never, because customers are so far removed from what you're doing. Because you got to focus. So what an incredible background. I love it. So let's dive into AI. AI has disrupted everything.
Yeah.
Even though it's
Indeed.
been around a long time, it's really only been the last 3 years since ChatGPT launched November 30th of 2022. That's what really brought all the attention to the world, and now we're seeing an explosion of AI. What effects has that had on your startup here?
Yeah. So there have multiple kind of impact of the startup. Of course, from the kind of internal activity, external activity, and customer engagement, right? So if you look at about Lightbits, we have 3 type of customers. Okay. By the way, I haven't mentioned it, but we at Lightbits, we invented a new protocol. Okay. And it's pretty unique for a startup to invent a protocol. It's called NVMe over
That's
TCP.
tough.
Yeah. And we haven't done that by ourselves. We actually had a few strategic investors like Intel, like Cisco, Micron, Dell, and others that help us kind of to bring it to the market, right? So you ask how we did, so it kind of impacting us. So it's from multiple direction. I will tell you. So we have 3 type of customers. One set of customers, e-commerce, very loud e-commerce. And over there, it's all about fraud detection, analytic, AI processing, and some of our customer, without naming exactly kind of customer name, have like 500 million customers. You can just imagine the intensity in their data center. Okay.
Oh
But
gosh,
think
yeah.
about think about if you go to kind of the Christmas time like we have now, or think about kind of you going to kind of Black Friday, the amount of intensity on the data center. It's all about transaction. I don't want to be an electron running there
Yeah, right.
in the data center. It's huge. So this is one type of customer. The second type of customer we have is financial. Okay. And this including top bank, insurance company, hedge fund, fintech. Over there, it's really about kind of the tight kind of processing, low latency, mission critical type of application. And then the last segment, which probably will be the topic most aligned to our discussion, is cloud provider and neo cloud providers. Okay, so those cloud providers, everybody's looking to now to kind of to host AI workload, right? If in the beginning, like just go like 5 years back, you had very kind of multiple general purpose public cloud, right? Of course, we have the large public cloud. Everybody familiar with Amazon,
Right,
Google,
right, right,
and
right, right.
Microsoft. Now there is kind of a new domain, a new segment of tier 2 cloud provider, and some of them being called neo cloud, which focus on GPU base, focus on AI, and this is where we are playing. So how it impact us? First of all, a lot of our development today is done with AI tools. Okay, it meaning things that related to code development, code review, different security analysis. So there's a lot of AI impact kind of in the day-to-day that increase the kind of utilization and increase the productivity, and adding kind of additional kind of consultant to every engineer. From our customer point of view, you see a change in the workload. Okay, the change in the workload is coming in two forms. One, there is one macro change that you probably familiar with, is the transition from VMware to a more like open
To bare
source,
metal or
exactly,
Kubernetes based. Yep.
containerized environment, Kubernetes. So this is one trend, and the other trend is AI. The two combined together, right? So the Kubernetes kind of become the default, let's say, orchestration platform, and the workload become AI workload. But yeah, let's take it to the next level.
So let's talk about the workloads a little bit, because those three industries that you talked about,
Yeah.
right, are data intense, but they're not. It's small amounts of data. It's not big blocks of data, right? Even the AI training that you're doing, you're talking about small bits of data that are being streamed through. How has that changed? Has that changed the profile of the data moving through the system? Where in the past, maybe I loaded a whole database up, right? Oh, big movement of data. Now it seems to me like I'm moving a lot of small packets. Are you seeing that? Or
Mm.
or do we still have the same mix, the profile mix that we had before? You know
Yeah.
where I'm going with that, Iran?
So it's kind of, so there's kind of, if we double click on AI specifically, right? So you need to kind of, there is two major activity. All of us familiar. There is training and there is inference. Okay.
Right. Yeah.
Training and inference is different by behavior, right? Training, you have access to all the data ahead of time. You say, okay, I'm going now to train of all the video, all the newspaper, all the
Right.
kind of insurance kind of contract that we had. If you are a bank, so you have all the transaction, you have all the data ahead of time, and it's a game of how fast you bring the data in. Okay, and it take you time. The training process may take like weeks or months, and it's all about throughput and readability. Super important. No, you don't want your kind of the job to stop and then recover everything from the beginning. You would be able to checkpoint and recover. Okay, so it's about
Gotcha.
throughput and large chunk in this case. Okay, the chunk is that you're bringing is
The
large.
chunks are big for
Yeah,
training.
you bring it into close to the GPU. You bring it. The CPU is the ones that initiate it. You get it into the DDR close to the GPU. Then the GPU get it even closer to the HBM. All of us familiar with kind of DDR. There's no DDR. Okay, let's wait 24 weeks.
Yeah. Yeah.
or,
Exactly.
or 1 year. Okay, I can get you DDR5. So that. So this is one aspect. The second aspect is inference. Inference is totally different. Inference, you have the
Well,
model.
wait. Before you go to inference,
Yeah.
on the training side,
Mhm.
I'm reading in big chunks, but
Yeah.
when I do a checkpoint, is that a big chunk out, or am I only sending small pieces back out? Because that makes a huge difference in the way that I architect my storage.
Correct. So it will still be kind of it will not be petabyte or megabyte, but it will be a chunk of like 128K or so on. Yes,
Oh,
you
so
will.
there's still pretty sizable
Yeah,
chunks that are
you will
coming
see.
out.
Yeah, you will send
Okay.
it kind of in a chunk, and then you have to register it from all the GPU together. You make sure that all GPU in your cluster actually register, and then you can continue to the next checkpoint, okay? And you can have a checkpoint every 30 minutes, every 1 hour, depending how kind of power need you are or kind of how critical your job. And it's a balance between stopping a job and continue
Right.
kind of, you need to do the basic trade-off. But
Okay, gotcha. So
but
that's training.
yeah, but you need to remember that for every AI activity, there is additional accessories, I would say. So there are databases that running in parallel that allow you to adjust a parameter, to allow you kind of to
Right.
get some kind of different tuning. And this will be a, let's say, regular database, and that could be a small chunk. And it will be intensive read, mainly intensive read.
A lot of
versus,
intensive
yeah,
read, not as much write.
correct. So
Gotcha.
this
Okay,
will be
so
kind of the macro processing in training. When you go to inference, it's different, right? So you have the model, okay? And now it's very interactive, okay? Think about an environment that you are hosting millions of customers now, okay? And it's kind of, let's say you're running your ChatGPT, or in your bank you're running some kind of an agent, tons
a
of
chat
agents
bot.
that
Yeah.
that's running a chatbot. All of them are running in parallel. So what do we see? It's very interactive. It can be small transaction. Because it's interactive now, latency is the king. Before of that, it was like throughput was the king, right? How fast you can get me all this chunk in so I can crunch it in my GPU. Now it's not just about GPU crunching. It's about kind of the latency, the interactive session. I have one agent put a task, another agent waited to the result, right? And now think
Right.
about thousand like them or more than that. So you need to manage a multi-tenant environment, multi-context environment. Okay. So
That's a
it's not
very
one stream of
different.
data. It's very different. It's a lot of stream of data. It's kind of multiple contexts, sometimes multi-model in parallel, and the latency have become more important. And it's also about now how you can get your GPU very efficient by just doing the job you need to do versus waiting to the data, waiting for the storage. Okay.
Well, so here's a good question I have on this. GPUs are not really made for that kind of interaction, right? They're mostly made for big chunks of data, right, coming through, not a lot of little small ones. So why even use a GPU in this case? Why not just use a CPU to do your inference?
Correct. Yeah, you're absolutely right. You will see some of the I would say even absolutely correct. What we see now in the transition period is that people using the training blueprint, okay, and use it for inference. But as inference becoming, people will look to make inference more cost effective. The cost per token, the power per token, all of that will come to play. People will start to see, okay, how I can customize my inference environment, how I can make it more efficient. And it's more than that even, because when you talked about training, you talk about very large environment, maybe a set of customers that will be expert in training, but inference will happen everywhere,
Everywhere,
every
yeah.
day, right?
Yeah.
So there's no one size fit all. Think about inference in the edge. Think about inference in your office. Think about inference on your mobile device.
Yeah.
So I
Well,
think
on my AI PC, right? I've got
exactly.
inference on my AI PC. Yeah.
Yeah, exactly. And you just want to do inference for your a blog, or you will do inference for a data kind of with a different set, smaller set. So I don't think there will be kind of one solution fit all. And we're going to see kind of fast forward, like maybe 6 to 12 months from now, custom silicon, custom devices. You will see workload offload to the CPU, which is much, much less expensive, less
Right.
power consumption. So it will be a combination of GPU, CPU, and custom devices that will host all of that together, right? And when you have your orchestration environment into the kind of the inference, the orchestration environment based on the input will have to select the right inference crunching.
For the right environment, right? Whether it's an
Exactly.
inference or training or
Correct.
right.
If you inference now video or text or audio, it will get different treating. Okay, the type of the models that you want to get.
Well,
So
This is
Yeah,
really interesting because it kind of flies in the face of the whole concept of cloud computing, which was I'll just throw a generic set of hardware in there that all the workloads can take advantage of, right? But what you're talking about here is specialized type of setups, infrastructure, whether it's a CPU plus GPU for
hmm
training, or CPU, maybe an NPU
yeah,
for inference and video inference. Maybe I have a VPU, a visual processing unit in there.
yeah.
So do you see that we'll move into more heterogeneous type of configurations in these cloud service providers,
I
or
do.
even in my own data center, right?
Yeah, I absolutely do. I think we are kind of two-step. Okay, step number one, people just let's get it work, right? And they will take the blueprint and many times the NVIDIA blueprint, and we use it for inference. Now, when they start to kind of to make, and if you look at all the neo cloud, they're also looking on kind of to go one level up in the food chain, right? They want to become inference as a service, okay? Instead of selling equipment and letting you
They
host kind
just
of
want to be
your
an inference service.
yeah,
Got it.
they want to be an inference service. You just come. I will give you an API. You have a route, okay, open route or whatever, and it's about kind of token per second. Your API become now token API. Okay, so
Yeah,
you
which
have
is an easy API. Yeah.
meta prompt in, meta prompt out, and now if I'm a cloud provider and it's not just about selling the equipment and scale, get access to GPU, making it cost effective, because now my margin will be based on the kind of how many
My
token
offer.
per second I could create, how much
Yeah.
power consumption I need to get for generating you the 1,000 token and so on. So when those cloud providers, and it's happening now, those cloud provider, basically we start to look at the economic of this, they will say, maybe I can do this work with a CPU. Maybe, as you mentioned, I can be VPU or NPU, and then I'll have different kind of environment. And because I'm on the entire inference, whenever I get an input, I know exactly which data set
Which
I will,
which
I will
element
move
I
it
want
to.
to use. Yeah.
Right?
No,
Right. And
that's pretty cool.
this is why we at Lightbits are pitching about kind of everything need to be software defined. Okay, and I explain you why.
Totally agree.
Because if you go with kind of the very kind of traditional model, okay, I put an appliance that will satisfy all my need. That means that you don't have the agility in the data center, right? You mentioned it before. I wanted to build a data center that I have kind of all the flexibility to shift workload between the compute into storage and to GPU. So I need kind of environment that is very elastic, okay?
Right.
It can be elastic at the time of the day. It can be elastic kind of at the time of the year. And of course, I can build everything to the worst case. But all of them know it's not economic. Building a data center today become more expensive than building a fab, right? In
I
the
know, it's
past,
crazy.
in the past, you say, okay, building a fab, do you have a $7 billion? Building a data center today, like a 200 megawatt, 300 megawatt, same number, $7 billion. Okay, you need the energy. You need to put kind of all kind of to host
Cooling systems.
cooling
I mean,
system,
yeah.
complete environment, all of that. So you need to be kind of more sophisticated and more kind of, I would say, um, uh, control on the way you're building it. Otherwise, it will, if you're building it in the wrong way, you build a cloud, okay? You get state-of-the-art GPU. Guess what? 18 months later, this is obsolete already,
Yeah, you got to
right?
throw them away.
So, right? So there's new generation. So you need to build your environment in a way that it's getting more like kind of sophisticated, agile, elastic cloud, and then to find the best way to host your environment. And it will definitely, as you mentioned, be heterogeneous. It will be a combination of compute and storage and GPU and networking, of course. And all of that, in my vision, should be a software defined.
Okay, so I have a question on that. I'm a true believer of software-defined infrastructure. It's part of the digital transformation architecture I've been working on is
Yeah.
software-defined infrastructure. For storage, we've talked about compute being specialized, right, for the different types of workloads. What about storage? do we see, because right now, I mean, we've got two major flavors, file-based and block-based, right? Or object-based, right? Object-based and block-based. Do you see a change in that as well as we get into different workloads that we've never seen before, especially at high volume that we're seeing, like with inference and the high volume in training? I mean, training consumes a lot of data. So are you seeing a change in data architectures or storage architectures because of this as well? Or can we lean on some of the things that we've been using in the past?
So it's an excellent question. And I think people are sitting today in multiple startups, including at Lightbits, and trying to crunch this question, okay? And to see kind of how kind of data center from the different kind of training model or inference model will look from the storage point of view in the next like 12 to 18 months. And let me double click on that, okay?
Okay.
So when we built kind of the first kind of NVMe controller, and we kind of built it kind of, it was kind of the evolution or revolution, you may say, from going from spindle into kind of flash, right? And it was very clear what we're trying to solve, right? With spindle, it was all about sequential. You need to have kind of a spin, and it was best tailored for the single thread, and then as kind of database and digital transformation you mentioned, and all of that came in a containerized environment. It was clear that it's all about random data, small chunk, right?
Yep.
And you need something different. And this was kind of leading to building the, NVMe over Fabric, and building kind of the new generation of flash controller that was fit for kind of latency, random access, versus sequential, and kind of a specific durability and endurance time and so on. Now, when you look at the GPU era, it's basically it's a great question, because today the GPU get all the data from the CPU. Okay, the CPU is sitting as a broker, right?
Yeah.
And
That's
he's
right.
trying to predict what the GPU will need. He's prefetching it into the GPU, and then the GPU crunch it. Okay, so it's kind of, there is the duality between the CPU and the GPU, okay? And if you think about kind of take it to the next step and thinking about customize kind of a XPU, let's call him, not just GPU, for different inference
XPU.
workload.
Yeah.
Maybe we need a direct interface between the GPU, the XPU, and the
storage?
storage and the memory. Okay, maybe there is a place for that, and I think the answer is yes. I think we need to come and start to build kind of a new data structure, a new kind of interface that will make it much easier to the GPU. You mentioned in the beginning of our talk, you say GPU was not kind of adjust or plan or for this type of workload, right? And this is true. GPU cannot run a very sophisticated file system. GPU cannot run a sophisticated kind of distributed object store. So
it's not made for that, right? It's made for
Exactly.
massively parallel computing.
Exactly. And so and you can say, okay, I can put some kind of sophisticated like memory controller. Remember in the past you had like just a memory controller. So we can have some sophisticated storage controllers in front of the GPU. So I think it will be the two things together. Maybe some of the work can offload into SmartNIC environment, or kind of and some of the work need to go back to the XPU or GPU, and it will lead eventually to some different data structure, I believe. Not necessarily for training, but more for inference.
Oh, you think more
that's
for
my vision. Yes. Yes.
So is that what Lightbits is working on? Is a new protocol for this? Where do you guys fit in this?
Yeah. So we
data path?
we definitely crunching this problem. Okay, and we already provide kind of solution today to as I mentioned, the cloud provider and neo cloud to kind of run the old workload, the existing workload today. And when you look at inference, it's RAG, and it's vector DB, and it's the inference process. All of that together, part of the package. And there is video inferencing, and there is kind of text inferencing. Each one of them is different. And the next step is to provide with an optimal solution for inference and in a more compact environment. And yes, we're definitely working on something like that. When you invite me to another podcast, maybe
we'll go deep.
Yeah, 6 months from now we can go deeper, and I can also.
All right. That sounds good. We'll have you back in 6 months.
Yeah.
So do you see things getting better then as far as OpEx cost? Because like you said, the CPU is the quarterback, right? The CPU is the guy in there directing traffic and all that. And if I can pull that out of the CPU and put it in possibly an accelerator chip, right? Or memory controller or something or storage controller that talks directly to the GPU, that will save an inordinate amount of time on moving data around.
Correct.
Because I don't have to go through a CPU and get context switched out and all the things that come with that.
So basically what we're doing now is helping people to redesign their data center of the future, right? Because as we mentioned, what they're using today, what's available, off-the-shelf component, right? And in a way, you would like to take the CPU out of the data pass, right? Today, the CPU is part of the data pass, while the CPU should kind of mainly focus on the orchestration, the control pass, on the kind of more sophisticated kind of software kind of aspect to execution, which the GPU is very routine on the type of execution. And I think this will happen. And Lightbits is definitely going to be there to offer solutions that help this to become affordable, I would say.
That's awesome. I mean, we've done this before with network, right?
Yes.
I can go network to storage directly. I don't even have to touch the CPU, right?
Correct.
Through accelerators
with RDMA, right? You have RDMA, you have kind of, so there's no reason you will not be able to do it here as well.
This is exciting. This is exciting stuff. There's so much happening in this space. If people want to find out more, Iran, from you, where do they go to find out more?
Yeah, so very easily, right? They can even contact me on LinkedIn. They can contact our website, lightbitslabs.com, and we more than happy to educate them and help them to design their system. We basically always feel that we are a partner of our customers, right? We're working with them together on the requirement. We understand exactly what they need, and we have the luxury of understanding. That's part of the DNA of the company: compute, storage, and networking.
Oh yeah, you do.
We are not just providing you kind of a point solution and tell you, okay, go and solve all the problem. We are more than happy to talk with you about the entire solution. Okay, how to architect your network, how to architect your storage, how to kind of optimize your compute, all of that together, and helping our customer to get the best kind of state-of-the-art solution. We understand that we are in transition point, and this is why software play kind of large part of that, because you need to adjust. You need to kind of your software as it is today will be different maybe 6 months from now.
Absolutely. Especially as agentic flows start coming up, you're going to see different data patterns and all that going on. Iran, thanks for coming on the show. And for my listeners, you got to tap into these superpowers. These are incredible superpowers. There's not a lot of people that can go at the silicon level, that can go from CPU or compute all the way through network and storage. There are not a lot of people in the world. So reach out to Aaron and Lightbits Labs. Thanks for coming on the show. I appreciate it.
Yeah, thank you for having me. It was great talking with you, Darren.
Thanks for listening to Embracing Digital Transformation. If you enjoyed today's conversation, give us 5 stars on your favorite podcasting app or on YouTube. It really helps others discover the show. If you want to go deeper, join our exclusive community at patreon.com/embracingdigital, where we share bonus content and you can always connect with other change makers like yourself. You can always find more resources at embracingdigital.org. Until next time, keep embracing the digital transformation.